Okay, you guys can see the PowerPoint slide on my back. Yeah, you can hear me clearly, right?
Yes, sir.
Okay, Nizam, you can see the PowerPoint slides behind me. Edmund?
Yes, sir.
Okay, good. Nizam, are you there?
Yes, sir.
Okay, good. Okay, let's begin. Today we look at chapter 2. So again, this is a structure. We have 1 test, 4 quiz, and 2 assignment, and 1 final exam. You need 80% attendance to sit for final exam. We are a little bit behind schedule, so we will go a bit faster. Okay. Okay, let me. All right. So, let me modify my slides for a while. Today we're going to look at chapter 2, as you can see from the PowerPoint slides. We'll do differentiation and integration. And if can, we cover differentiation of inverse trigonometry, hyperbolic, partial fraction, parts, and formula. This one we will cover one by one. But at the moment, I will recap, or I will refresh your understanding in differentiation and integration first. Then we go into a more deeper inverse trigonometry and hyperbolic function. Okay, that is what will happen in our class. Okay. I need all of you mute your mic now, because one of your mic is feedback back to this Teams. Okay. All right. First, just recall, what have you learned in your differentiation class? Max 1. So you look at polynomial and exponential function. So again, if you have y equals to c, means you have a constant value, and you plot in the Cartesian plane or Cartesian axis, you have x and y axis, and your y equal to a constant value means you draw a straight line there. Your slope, your dy dx for this straight line will be 0. Okay, so this is the basic concept when we deal with differentiation. So recall, when you dy dx of a constant value, you'll get 0. Recall, this is just a basic understanding that you learned in Max 1, right? So when you differentiate a straight line or differentiate a constant value, will be 0. Or what is dy dx? What is differentiation? Differentiation basically it is the slope or gradient of the line. If you talk about linear equation, y equal to mx plus c, if you differentiate the y equal to ms plus c, if you have a straight line, then you get 0. Okay, so this is the first recall that you learn. So dy dx, if you dx or you find the slope of a straight line of a constant value, then you get 0. Remember, this one you'll be tested in test 1 and also final exam. This information will not given in exam. Means we expect you to know when you differentiate a constant value. Okay, Shakir, I'm going to ask you a question about this one. Remember this formula. When you differentiate a constant value, you get 0. Or your y equal, let's say your y equal to 2, y equal to 6, one number, y equal to 10, you dy dx, you get 0. Shakir, I'm going to ask you this question later on. Okay. This is called derivative of a constant function. Constant function means your y equal to one number, y equal to 4, y equal to 100, and so on. So if you differentiate a constant value, you get 0. The next one. If your function, your power function, if you look at this graph, y equal to x, or if you look at straight line equation, y equal to mx plus c, your c, mx plus c, your c is 0. According to graph, your c intersection point is 0, your m is 1. Dy dx equal to 1 if you have y equal to x. Or mathematically, you are given a line, y equal to ms plus c, you want to find the slope. If your y equal to x, your dy dx equal to 1. So for example, this is the mathematical model. You are having a function y equal to x, you dy dx, you differentiate x, you get 1. Okay, you differentiate x, you get 1. Okay. So what happened? We increase the power of your equation. Y equal to 2x, y equal to x power 2. Your dy dx, now x is power 2. What do you get? Let's see if you remember. Nizam, what do you get if you differentiate x power 2? What do you get?
What's that?
What do you get? If you differentiate x power 2, what do you get? If you differentiate x power 2, what do you get? What is the answer?
2x.
2x, huh? Okay, correct. Equal to 2x. What happened if you differentiate x power 3, Edmund? What do you get?
3x squared.
3x squared. Correct. So by looking at this pattern, again, this module will always test you to derive a pattern. So if your n is positive, you can write x power n when you differentiate with x. Okay. What happened to your n? Your n keep decreasing. Right? You're equal to, you always pull your n to the front, right? You always pull your n, let's say 3x power 3, you pull your 3 to the front, and your n you always minus 1. So that's why you, by looking at all this pattern, if you differentiate how many times, you get n x n minus 1. Any question for these slides? Any question? Shakir, you understand how you get this pattern? How you get this pattern? Shakir, you okay? Shakir, do you understand how you get this equation?
Yes, sir.
Okay, good. All right, so this equation we call power rules. Okay, this is what you learned in Max 1. Power rules mean if you differentiate x power n, you pull your n to the front, x, the n will minus 1. This is how you do differentiation. Okay, I think all of you able to do this one. Okay. Okay, I apologize for this one. I do not hide this one. So just recall what you learned in Max 1 in differentiation. So the question asks you to differentiate this one and this one. Okay, Nizam, you want to try? What will this be? what is, if your y equal to 1 over x power 2, what is the answer if you differentiate a, if you differentiate this one? Nizam, do you want to try? What is the answer? Edmund also try standby. Shakir also try to standby. What is the answer for this one if you differentiate this one? Okay, Nizam, you try. Let me give you another 30 seconds. By using the power rules just now. Now, if you don't like fraction pattern, you can write in the exponential.
So x minus 2 become.
Okay. So yeah, so this one is equal to x power negative 2.
Okay, x minus 2.
Uh-huh.
Bring it in front, become negative 2 x minus 1.
So what is that?
No, not minus 1, minus 2, then plus minus 1. So
What is the final answer? Minus 2 x what? X power what?
X power negative 3.
Okay, correct. So again, recall back what you learned. If you differentiate a power equation, x power n, you pull the n to the front, and then the power, there's a negative 1 there. So by looking at this one, I don't like fraction format. So if you like, you can continue to solve. But I don't like this format. I always like exponential. So I write in this form. Okay, this one equal to x minus 2. I use this equation. I pull the negative to the front, and then the minus 2 minus 1, I get minus 3. Okay, so this is the way you communicate. You write f comma, your function, f comma this one, equal to dx, this one. So this is the steps that you do. But in future, I will not show you these detailed steps. I will expect you to know already because you have come to Max 2. So this one, you should able to jump steps like what Nizam did just now. Okay, so here you will get minus 2x negative 3. You can stop your answer here, or you can rewrite back in a fraction. Both give you same marks. Either this one or this one give you same marks. Okay. All right. So Nizam already solved this one. Edmund and Shakil try to solve. Yes, go ahead.
The negative is front, right? But then here I wrote 2. Because of the negative 2, I only put 2 over x power of negative 3. Is it
Okay.
same?
You see the negative in front here?
Yeah, no, that's what I meant. Negative 2,
Yeah,
I put
this one.
up to become positive.
Negative 2.
I put up, right? So it becomes
Yeah.
positive 2. And then
Yeah.
over x power of negative 3, right?
No, if you write negative 3, it means 1 over something. Negative means, you see this one?
Yeah.
So you just rewrite back from this form to this form. This one is from the left to right. This one is from the right to left. You see?
Yeah.
1 over x power 2 means x power negative 2. So this is what you write just now. Minus 2 bracket x power negative 3. What does x minus negative 3? It means minus mean 1 over. 1 over.
Brought up and then negative stays there. Okay, yeah, understand.
Yeah, so means you use the divide already. You already take out the negative. Means you already transform the negative meaning into divide. Then you get a positive number.
Okay,
if you write a negative here, it means you inverse the x up already, because you divide. One more time. So this is just a basic concept Just to recall, this actually meaning the same. Either you write in fraction or you write in exponential. Same meaning. But I like this exponential pattern because it's in the horizontal line rather than this one. Okay? Yeah. So B, Edmund, you want to try to solve this one? Edmund, are you able to write this form into exponential? Like for example, this form. Are you able to write exponential form like this? What does this mean? X power what equal to this one? Edmund, what do you think? Edmund?
Yes, sir.
Yeah. So if you want to convert the square, the cube root into exponential, how do you write? X power what? How you write square? How you write square? X square root equal to what? Or you forget already? Shakir, you want to try? How you write
X
this
to
one?
the power of 2 over 3.
Correct. That one Shakir, right?
Yes, sir.
Okay, good. Edmund, remember, huh? So you can write this one in this one, okay, in this form, huh? This one equal to this one, huh? So just recall, for this module, we expect you to know how to do conversion already. This one is 1 over something. You can write in this form. This example is to recall what happened if you have a square, there's a root there. In this one is root 3, so 1 over 3 here. 2x power 2 you continue to carry, but you have a cap, then it's 1 over something. Okay, over something. Okay, so if this one is 2, then this is 2 lah. Okay, if this one is 4, then this one is 4 lah. Okay, so this is how you write. Okay, but however, the question asks you to differentiate this one. Okay, Shakir, you want to try to solve this one? When you differentiate this one, what do you get?
2 over 3 x to the power of negative 1 over 3.
Negative 1 over 3, correct. So you pull your 2 over 3 in front. This one minus 1. You'll get minus 1 over 3. Again, you can stay your answer this form, or you can write in the fraction form. So if you write in the fraction form, or you expand this one, minus 1 over 3, it will be, if you get a negative there, it means 1 over something. Okay, it will equal to this one, huh? It will equal to 1 over something. Okay, I think I miss out the square, the root, huh? The root. Okay. There's a typo error here. This is not. I think I made a mistake there. Let me correct right away. This is 1 over 3. It will be square root of 3. Sorry. Square root of x. Okay, what I did just now is that, sorry for blocking your view. What I did just now, I changed the answer to this one. Huh? Okay. Just now, I have a wrong typo error in my slides. Huh? So it will be minus means 1 over something. 1 over something means you have a root. So 1 over 3 means root lah. So like this one. Right? Just now, Shakir already tried to explain this one. So if you have a cube root means 1 over 3 here. Okay. So at the end here you also get 1 over 3, but you have a negative sign means 1 over something. Okay. This one related to this example. Okay, so there's a typo error in my slide just now. All right, so we have a review a normal differentiation. Now, what happens if you have a multiplication in your calculation? So, for example, if you have a constant value times y, for example, 4y, or y equal to x, for example, y equal to ms plus c or so. But how you can rearrange the differentiation? If you have a constant value, you can pull your c from inside the bracket to outside. Then you focus on the function to differentiate. Okay, so this is the first rules. So if you have a constant value of a function, you can pull your function, your constant value outside. This is the first one. For example, if you want to differentiate 3 over x power 4, what you can do, you can pull the 3 outside. In this case, you compare side by side, the top and bottom. You can pull the yellow color c. In this one is equal to 3. You can pull your 3 outside. Okay, you can pull your 3 outside like this one. And then you only left out to differentiate x power 4. Shakir, what do you get? X power 4. You differentiate x power 4, what do you get?
Four x to the power of 3.
Okay, good. So the answer will be 12 lah.
Yes.
Okay, it will be 12 x power 3. So correct, just now this one. Okay, so we get this one. So this is how we apply these rules. Okay, if you see a constant value, you can pull outside first, then you solve for the x power something. Okay, you solve for that one. This is called differentiation. Later we look at integration. Okay. Next, if you have two functions, just now it's a constant value. Now we look at sum and differences, means you have positive. You need to plus two functions, let's say y1 and y2. So you can break them into two different steps. Or on the top, this one is positive. You plus two functions, or you can minus function. So positive, negative here is the same. You just, if you have two functions and you need to differentiate them, you can break them into two parts. You can differentiate the first part, then you do the second part, then you combine them together. If you have a negative, also same. You have a negative, then you do the first part, you minus the second part. You just break into two operations. I'll give you one example. So this is second rules, how we solve differentiation. So I'll give you one example. Okay, you want to differentiate this function in the bracket. So I write d dx the bracket. So how do you solve this kind of problem? If you have this, look like complicated, but actually not. Don't scared by the x power something and so on. This is actually is a polynomial equation. You copy the question. You want to differentiate this one. Actually, by using these two rules, you can differentiate one by one. Don't be scared by this bracket. You can break them into 1, 2, 3, 4, 5, 6 steps. As you can see in red color steps here. From, it looks very complex, but actually when you have plus and minus inside the equation, you can break them into individual calculation. Okay, Edmund, you want to try? What do you get for the first one? X power 8, you dx, what do you get, Edmund? Nizam, you ready for the second one? Shakir, you ready for this one? Edmund, what is the answer, Edmund?
X power 7.
x raised to the power 7. Nizam, what is the second one? What is the second one, Nizam? This one?
16 x 4.
Power, what?
Power 4.
4, correct. Shakil, what is this one?
16x to the power of 3.
16 positive, negative?
Negative.
Okay, good. Okay, Shakil, what does this one equal to? The rest, I think you can do this one.
0.
Okay, correct. Now all of you know how to do already. Okay, so then I can go very fast after this. So we already recap or refresh what you learned in Max 1, how to do differentiation by these two examples. Example 1, example 2, most of you can do already. So this is how you do. Okay, don't scared by the bracket and the long equation. Just remember that when you have a plus negative, you can break into individual, then you combine them back. Okay. Example number 3. This one is more on application. Apologize for this one. I missed out the translation in the PowerPoint setting. Okay, so let's look at the question. The equation of the particles given you by S equal to this equation. So basically you have a displacement and the time. S equal to 2t cubed minus blah, blah, blah. So this basically, if you don't be scared by the S and T, you just see this one as Y, this one as X. Y equal to 2x power 3 minus 5x power 2 plus 3x plus 4. You can see it that way. Okay. This question because you apply it to a motion. So that's why you use the S and T. So S measure in meter, T in second. Find acceleration as a function of time. What is the acceleration after 2? So S is a distance travel by the particle. What is definition of acceleration? Shakir, you want to try? What is acceleration? How you get acceleration? You take what divided by what?
Velocity time.
Velocity over time.
Velocity over time. Okay, correct. How you get velocity from distance? Velocity equal to what divided by what?
Distance over time.
Okay, so this is a distance equation. So can you do from these steps to acceleration step by using the concept that you just do? So solution. So you know that if you differentiate this equation, this is a distance, you differentiate over time, you get velocity. All right? So don't get scared by this equation. Basically, what we done in example 2, you break this one individual, 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 individual. You differentiate over time. This is a distance over time. You get velocity. So, yeah. So this is basically what the equation about. Okay, I don't think I need to ask you lah. You know how to do already. I straight away give you the answer. So again, to get the acceleration, you just differentiate one more time after you get the v. So this is what we covered just now in example 2. So this is a bracket and you differentiate this one, this one, this one, this one, and the most easy one is this one. Okay, you always get 0 when you have a number. So this one you get 60 t power 2 and so on. So I believe you can do the differentiation on this set already. So I just give you one set, the first set, second set, third set, and the last one. This is the equation for velocity that you derive from the distance s. Then you use this equation, put in the definition of acceleration, velocity divided by t. You take this one, differentiate. Again, you see a bracket of equation. Inside bracket, you have a positive, negative. You do the same concept, differentiate each one of it. differentiate each one of it. So I no longer write this one out because we go a bit faster because you already know how to do this one already. So I jump these steps to these steps. I didn't write this one out already. So this one, you dt, you get 12t. This one, again, remember, one mistakes done by student, they always forget the negative sign when they work to the next steps, okay? Just remind yourself. So always carry the negative into your answer. So this one, you dt, you get 10. This one, you know lah, get 0. Okay?
Hello?
Yeah, go ahead.
Ha?
Who is mic on?
Saya tak reti ni nak send sebab benda tu dekat benda dokumen tu dekat Google Classroom.
Excuse me, Shakir, are you answering call? Or anyone answering call, your mic is on. The whole world know what you're talking about now. Please mute your mic there, if you don't want your conversation to be heard around the world. Yeah. Okay, so at the end, you arrive at acceleration equation, 12t minus 10. So you have two equations here. One is for velocity, one is for acceleration. The question asks you what happened acceleration after 2. So acceleration at t equal to, what do you think? Edmund, what do you think? Acceleration after 2 seconds? What is the value you get for acceleration after 2 seconds?
Yes, sir.
Yeah, what is the answer for this one? After 2 seconds. Amen. What is the answer?
Four.
Answer is what? After 2 seconds, what is your acceleration?
4, sir.
Your answer is 4. How you get 4? Can you explain?
12 minus 10.
Do you see this one is an equation?
Oh, yeah, yes, sir.
So what equation you see?
12
What equation you see? 12t minus 10. The question asks you acceleration after 2 seconds. What do you substitute here? T equal to what?
T equal to 2 seconds.
T equal to?
2.
T equal to 2 seconds. So what do you get? 12t, what do you get?
24.
Minus 10, what do you get?
40.
Again, your answer? 40? Your answer is what? 40 or 14?
40.
Do you know what is 40 means?
40.
Okay, give me a number. What do you get? What number you get? 1 4. 1 4 is 14, not 40. Okay? So, yeah. Okay, so the answer will be answer 40. So again, you are minus there. It's not 40. It's 2 seconds. So this one, 12 multiply 2, 24 minus 10, you get 2. Edmund, do you understand what mistake you do just now?
Oh, yes, sir.
What mistake you do? What mistake you did just now? How you get 14 just now? What mistake you do? Amen. How do you get 1/4 just now?
I let the 12 multiply 2 and minus 10.
Just now what you do? Is it the correct answer?
Yes, yes, sir.
This is the correct answer. Amen. Nizam, do you spot anything weird on the slides here? Somebody spot any mistakes that are done here? Shakil, can you spot anything wrong from this step to these steps?
Kesimpulan saya ada je perempuan yang dia cakap nak kenal dengan dia semua. Tak adalah terus pergi segang perempuan tu sebab
12 is it? Sir?
So the answer should be what?
The answer 12 ms square, m over s square.
So I did a mistake here.
Yeah.
1 is missing there. So
Yeah.
So check. Okay, so there's a mistake here in on my slides here. Okay, yeah, I'll purposely left it here. So see if you're able to spot. There's a mistake here. Okay. All right. So we have done for polishing your understanding in getting how you apply the differentiation. Okay. Next, exponential. What happens if you look at E? This one, the E. If you limit your E power h minus 1 divided by h, you'll get 1. Okay, if your h near to 0, your E will get 1. So just remember that you have one equation. When you solve the E, you can use this natural exponential function to define the question. Okay, just remember that you've seen this one before. E power h minus 1 divided by h. You put a limit there, you get 1. Okay, you put a limit there, you get 1. So for example, if you need to differentiate E power something, you'll get back the same answer. I'll repeat. If you solve a question with E or natural exponential, E, you differentiate E power something, you get back the same answer. Yeah? This is when you deal with E power something, you get back the same answer. Let's look at this example number 4. If your function equal to E power x minus x, find f comma means you differentiate 1 time, and f comma comma means you differentiate 2 times. By using these slides, if you differentiate ex, you get back the ex. What do you think if you differentiate 1 time? Y equal to, or fx equal to ex minus x. And you can break this one into two operations. You do the EX and then you do the minus X. What do you think you get? Okay, what do you think you get by using this formula? You differentiate EX, you get back EX. So what do you think if you do this operation? Nizam, can you try to answer? If you differentiate one time, what do you get?
EX, sir.
EX what?
EX minus 0.
You minus X, you differentiate one time, what do you get?
Minus X.
You only answer the first part. The second part, where is your minus X? Minus X, you differentiate. Differentiate X, what do you get? Do you understand my question? You can break into two operations here.
Yeah.
You do one part for EX, then you do one part for minus X. EX you already answered just now. What about minus X? You differentiate minus X, what do you get? You differentiate minus X, what do you get? Minus X, X power what?
1 over X. X power.
Minus X upside up on the top of X, what do you get? X power what?
X power 1.
X power 1. But you do differentiation, what happened to the 1?
1 come from 1 to 1 is it?
You power 1, right? Just now you power 1, but you do differentiation. Differentiation, what do you do to the exponential?
Bring in front and then minus 1.
Okay. 1 minus 1, what do you get?
0.
0. So X power 0, what do you get?
1.
1. So you have negative 1, negative X, you get negative 1, correct? You differentiate this one, you get the same number, but negative X is, you do the X first. X power 1, 1 minus 1, 0. X power 0, you get 1, minus 1. The answer is minus 1. So you do these two parts. If you really cannot do, you just pull the negative out. So this one you get EX. This set you get 1. So EX minus 1 is the answer. Do you see this one? Lisa, do you understand? Here, you get this one, you get this one. Okay, now, Shakil, do you want to do the second part? If you F double comma, means you differentiate this one more time, what do you get?
Cantik. Hai.
What do you get? You can break this one into two.
Lon.
So,
Is lon, right, sir?
what does this slide tell you?
Derivative.
You differentiate EX, what do you get?
EX.
Back to this question.
Okay. Alright.
You differentiate one more time.
So
You break into two. EX equal. This part equal what?
EX.
EX. Then this one? This
0.
one you expert already. So answer is what?
EX.
Answer is EX.
Yes.
Okay. So again, this is just a practice what you learn in Max 1. So just practice. So later we'll look at more complex one. So this is just a normal, just recall. All right. Any question for these slides? Edmund, you okay?
Yes, sir.
Okay. Let's one more example. Okay. Okay. Let's go for the example. So at what position on the curve y equal to EX is tangent line parallel to the line y equal to 2x? You have two equations here. You have curve EX, and you have one more line y equal to 2x. This is a linear equation, and it say that you have a parallel, means the gradient is the same. The slope of this one is same as this one. So if you look at this linear equation, y equal to mx plus c, what is the slope of this equation, Edmund? What is the gradient of this equation? You learn about linear equation, right? Y equal to mx plus c. What is the m? What is the gradient in this equation? Edmund, what is the slope of this equation?
2.
2. Y equal to mx plus c. Recall, go back to your mathematics textbook. What is y equal to mx plus c? What is m? Okay. Gradient is 2. In this question, it gives you two equations. This one, it say that this equation, you find the tangent of this equation, and this tangent is parallel. Means the m, the dy dx of this equation equal to 2 of this equation. Okay, try to understand what is this question asks you. Just give you a hint. This one going to be your coming quiz 1 question. Try to understand what this question asks you. He give you two equations. He say that this one, the tangent line is parallel to this line. So this line is a linear equation. In this linear equation, you already have the gradient. The slope is 2. So once you find the first line, this is the line equation. You dy dx, you get the slope. The slope is same because the wording of parallel. The slope dy dx will equal to m of this equation, which is equal to 2. Then you manage to find the point. So dy, you're given the y equal to ex. Shakir, what is the answer dy dx of this equation?
EX.
Okay, correct. You get this one. Okay, this is how you write lah. Y comma means you differentiate one time. Dx, ex, you get ex. So this is a slope again. Dy dx means slope or gradient. About how the line will plot. Slope is just the gradient. Okay, slope. So it tell you it parallel to this line. So this line already give you the slope number, which is 2. So again, there's online tools to illustrate. I'm not going to show you, but you can Google. You Google graph plotter, or later when you open up these PowerPoint slides, you just click this link. It will bring you to the online plotter. You can key in the equation to plot. So the red line, this graph was generated using this online plotter. This, okay, how do you access to this one? You just go to Google. You Google graph plotter, graph plotter, GRAPH-PLOTTER, graph plotter. If not mistaken, it will come out as the first link or second link. You click that one, you will come to a website. So that website, on the left-hand side of the website, you can key in the equation. First equation, you key in E, y equal, you just type in y equal to ex. It will generate red line on the website. So this red line is ex, y equal to ex. And how do you plot this blue color? You just type in y equal to 2x in the website. You get the blue line, this blue line. So he asks you at what point at what point along the ex is parallel to this line. So you know that the slope of this line, y equal to mx plus c, this blue color, the slope is 2. So just now you define the slope of this red color, which is dy dx. Shakir already answered the dy dx equal to ex. So ex equal to 2, you manage to find a point along this slope that parallel to this line. So Ex, y equal to 2x, y equal to 2x, so the slope will be same, Ex equal to 2, and you convert to find the x. E power x equal 2, you convert, you find the x, you do the long procedure like Shakir tried to attempt to do just now. Okay, e power x equal 2, you want to solve the x above the e, what do? You use the ln, you convert into ln, x equal to ln 2, use your calculator, count what is ln 2. So x equal to ln 2, okay, x equal to ln 2, so means the position of x equal to ln 2, if you press calculator, you will be somewhere here. Okay, it will be somewhere here, you go up, you meet a point, you move to the left. Means if your x equal to ln 2 means e power ln 2, you get one answer. Okay, so this is the point where you get when you substitute your ln 2 into the equation, because your this line equal to y equal to e power x, you substitute the location x ln 2 into this x here. So e ln 2, e power ln 2 equal to 2. Okay, so that's why you get this black dot here. This black dot is the answer for example number 5. The answer will be ln 2, 2. This is a Cartesian coordinate. Ln 2, 2, or you can give a decimal place. Okay, use your calculator. Is this location? You move up, meet the point, move to the left, you get your y value. So ln 2, 2, or you can substitute your ln 2 into e power x. E power ln 2, you get 2. Okay, this is how you answer. Any question for example 5? Just give you a hint, this one will be one of your quiz questions. I will test you whether you understand what is parallel. I'll give you 2 equations. You need to do differentiation. On the first one, you get the gradient. You equal the gradient together. You solve the question. Find the point that parallel. Or find the equation that parallel. The both lines are parallel. Any question for example number 5? Edmund, you okay?
Yes, sir.
Nizam, okay? Shakir, okay?
Yes, sir.
All right. We have done, we have covered the constant value. We have done the positive, negative function. Now, and then one more, the EX just now. And then what happened to the multiplication and division of function. So, if you need to multiply 2, you have 2 functions that multiply together. What do? You use the you use the product rules. What you do, you break into 2 parts. Okay, don't confuse this equation with. Yeah, I need to go back to one of the slides. Don't confuse with. Okay, don't confuse with this one. This one there's a plus between the 2 functions. Don't confuse with this one. This one is a product rules where you multiply and divide. So if we have two functions that multiply together, the procedure is to break into two parts again. First, you use the first function, fx, then you differentiate the second part, plus the second function, gx, and you differentiate the first part. You break into two operations when you have a multiplication or products operation. Try to understand what is this equation about. Ask me question if you don't understand. It means if you have a times b equation, all right, so this one you a and then you do the b, dy dx the b, plus the b and then you dy dx the a. It is how you do when you have a multiplication. Let's look at this example. So your y or fx equal to x e power x. Find, differentiate this equation. F comma means differentiate. So look at this equation. You have two functions multiply together. So what you do, you take the first function, multiply by the differentiation of the second one, plus, and then you flip the position. You write the second function, and then you differentiate the first function. So using this equation, solve this equation. Can you see that there's a two function inside the equation? Can you see the pattern? What is fx in the question, Nizam? What is fx equal to the equation?
X.
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 No, I mean x multiplied by ex, right? You can break into two functions, right? My question is, what is fx?
Fx is only x.
Yes, gx is e power x. Okay, so this is the function or equation that we see just now. So you follow the procedure. Just now, Nizam already tell us fx equal to x, gx equal to e power x. So you just follow the procedure. You put fx equal to x, and then you divide dx, the ex. You do one more set for gx, multiply by d power x. Let's see if you're able to do. So you write, this is the function given. Second line, you write f, comma means you dy dx, or d over dx, the function. You compare side by side this function. Then you modify this equation according to the question. Okay, so this is what Nizam tell us just now. Fx equal to x, gx equal to ex. Then you use this equation. So what you do, fx equal to x, then you dex. Okay, I think Shakir already expert already. Shakir, what is this answer will you get? Shakir? dx ex, e power x, you differentiate e power x, what do you get? This one Shakir expert already. Shakir? Shakir?
Yeah, sorry, sir.
Yeah, what is the answer for this part? I mean, if you substitute fx equal to x and then you differentiate gx, gx is ex. So you are expert in the differentiate of ex already. So what does this answer will give you?
X, EX, is it?
Yes, correct. The answer is x times ex for this part. Okay, because if you differentiate ex, you still get ex. Then you copy. What is your gx? Your gx is ex, so write ex here. Differentiate fx, your fx is x, so you write dxx. I think this one Nizam expert already. Nizam, what is this answer? The second part, second portion. What is the answer of differentiation of x?
1.
1. So 1 times EX, what do you get?
EX.
Okay, so the answer, you combine the answer of Shakil and Nizam. So the first one, you get this one, plus this one is the answer. So then if you're hardworking, you factor them out to factor the EX out, and then you pick a bracket X plus 1. Okay, since you're doing degree already, so always put your answer in more simpler form. Okay, put this one in this one. Okay, factor, then put in the simplest form. We put this question further. What happens if find the n derivative of fn power x for this one? If you use this one to derive an equation for future person, because this one you multiply one time, you get this one. What happens if you need to differentiate n time? What does the pattern that you see? So you just copy the rules that you learned just now, and then you do certain times, a few times. You divide the x 1 time, 2 times, 3 times, and then you see the pattern. Then you write the general equation. Okay. Okay. So over here, just now what we get, this is our function fx equal to xex, and then fx. Sorry, I'm using the direction a bit flipped on my side. So, okay, fx, this one already solved, equal to this one. This is an answer from Nizam and Shakir just now. What happens if you do one more time? If you do one more time, double differentiation of ex power x, what do you get? Again, you pull the ex out. And then, I mean, this one is another function of this one. So if you need to differentiate the multiplication between two functions, ex is a new function now. Bracket x plus 1 is the gx now. You use back this equation, fx, you substitute, differentiate gx here, plus gx is this one, differentiation of ex. So this is the first set of this one. First set. That's why fx equal to this one, and so on. Okay, this is the second set. You get this form. Okay. So I think I flipped the fx and gx, but anyway, you can flip the sequence as long as you follow the rules of this one. As long as you follow the fx and gx, and then you put in the equation. Okay. So at the end, you arrive at xs multiplied by ex. Okay. So this one, you get this one because you x dx, you get 1. You get a number here. Dx, you get 0. So only have 1. And here, Shakir explained already. This one, you differentiate, you get ex. Then you combine this equation, you get ex, x plus 1 plus 1, you get x plus 2. Okay. When you differentiate 2 times, you get ex, x plus 2, and then you compare this one, differentiate 1 time, you get this equation. Differentiate 2 times, you get this equation. And if you're hardworking, you do one more time, right? You're working, you do one more time by applying this red color equation. You can substitute this one. This one is fx, this one is gx, or this one gx, this one fx also can, as long as you substitute the correct equation here. You do the third time, differentiate the time by using this equation. Do the same, I repeat the same. You rearrange the equation. You get exx power x times 3. You compare this one and you put back here. You see a pattern. Okay. Do you see a pattern here? 1 time, 2 times, 3 times. And what is the difference? Let's say this is 1. 1 comma is n equal 1. This one 2 comma means n equal 2. This one 3 comma means n equal 3. What is different here? When this one is 1, you get 1. When this one is 2, you get 2. And this one you get 3. You get 3 here. Means what happened to your n? Can you write a general equation to define from this one to this one? I think you can see, right? This one is more hardworking. I do 4th time. Okay, do 4th time. You get x power 4. Then you put them together. Okay, put them together. And then I already explained you the pattern. I do one more part. If this one is 4, you get 4 here. So write this pattern and this pattern in general equation in this form. F power n, not power lah, but you differentiate how many times x equal to what? Okay, can you guess? Can you guess what is the answer? If the question asks you to find, let me ask you to find this one. Ask you to find this one, the general function, by looking at this 4 equation here. 4 equation here. So f power nx equal what? Nizam, can you tell the answer? By looking at this 4 equation, 1, 2, 3, 4. Fn power x, fn bracket x means the function, equal what? What is the n that changing in here? Nizam, you want to try? What is the answer for this one? For this question? By looking at this set, this 4 set. Equal to what?
Plus
Equal to?
equal to x plus n.
No, I mean, part of the answer is s plus n, because you see the 1, 2, 3, 4 is changing according to n here, correct? Yeah. But you have to copy the body of the same formula here. So f and x, e power x bracket x plus n is the answer. Okay, it's the answer. I'm using green screen, so it's a flip direction. So, okay, this one you derive from this 4. Okay, you compare this one and this 4 equation, you get this pattern. Okay, this one I will let you to example 8 is another extra exercise. So it asks you to differentiate, then you differentiate lah. Okay, so differentiate towards what in t? Yeah, all the example before this is x, but now it's t. So inside here is t. You just assume this one is x lah. So function x, but now it's t. So you replace t as your x, then you do like the previous one. Okay, I'm going to skip this one. You do this one as your homework. Okay, one more, then we call it a day. Okay, just now we do the multiplication. What happens if you have divide like this one? You have 2 function or 2 equation, but now you do the differentiation when you divide two equation. Okay, you use this formula. Okay, basically you don't need to memorize, but the slide is available to you. You only need to know which formula to refer to. So you have 2 functions. One is the fx on the top, one is gx on the below. And you just refer to this equation to solve. How you use? You take the below one, the gx, and then you differentiate the fx minus fx, the top one, multiply by gx, you differentiate the gx, divide by gx power 2. This is just a general equation. You just substitute this whole equation according to the question. If you need division or you need quotient rules. So this one works for differentiation. Or you can, yeah, okay. So I think this one you learned before. So we just recall all the basic information today. So let's look how we apply. Okay. Now the question asks you to differentiate this one. Let's say your y equal to top function divided by bottom function. So this is a quotient rules. You need to use quotient rules. So you have two functions there. Then just now we teach you there's an equation for you to apply. So you just apply. On the top is fx, the below one is gx. You just substitute inside there and then do the normal differentiation accordingly. So you look at the question, copy the general equation. Copy the general equation, this one. So you compare side by side, the red color and the blue color. You can see that fx equal to top one. This one equal to the top one. So fx equal to x squared plus x minus 2. Then the gx equal to x power 3 plus 6. Then the rest is just application of this formula. Gx, you substitute this one over here. Then you multiply with the differentiation of fx of this one. Minus, again, if you divide one, you use minus. Minus fx. What is fx? Fx is this one. And multiply by differentiation of gx, which is this one. Then below one is square. The function, the whole function you square. Okay. Let's do a little bit exercise. Nizam, can you do the differentiation for fx? What does it end? If you differentiate the top equation, what do you get? If you do only this small part. This is your f equal to what? Yeah, this whole set. 2x plus 1 equal to this dx fx. Good. Okay, Edmund, next question for you. You do differentiation of dx. What do you get if you differentiate x power 3 plus 6? What do you get, Edmund?
3s power 2.
Then this one equal?
Equal to 0.
Correct. So the next step is just substitution of what the answer given by Nizam and Edmund. The rest is just substitution. Okay, so your fx equal to, sorry, gx. Gx is below 1, so gx equal to this one. So you substitute this one, bracket. And this one is a step that done by Nizam just now. And minus, again, this is the area where students make mistakes. This is the whole thing. From here to here is one set. So when you do the calculation, I will recommend you use a big bracket to contain the second term here, because sometimes you forget that there's a negative multiplied by the whole thing. Okay, so I will recommend you to use a big bracket to bracket here until here, so that after you do calculation, you multiply the negative inside. For safety lah, okay, for safety. So you this one already done by your classmate just now. The rest is just mathematics lah. Okay, you rearrange, you multiply. You can do multiply, right? Column plus column, and then this one also you multiply, you rearrange. Very lengthy. we arrive at the yellow color box here. Okay, so this is how you do quotient rules. Another one, as you can see, you repeat the same concept. Find the equation of tangent line. I see. Equation of tangent line. It means it asks you to find dy dx. Equation of tangent line, it means you find dy dx. I repeat, you see the word, it asks you to find tangent line means dy dx of the equation. So you are given one equation here. It asks you to find tangent line of this one. So basically it asks you to dy dx of this one. Differentiate this one. And you look at the question, this equation actually top divided by bottom. So you use the quotient rules that you learned just now. Fx above, gx below. You do the calculation and then you're given a point. You're given the x point and y point. This is the coordinate. So this is x, this is y. After you do the differentiation, he asks you what is the equation. So you just substitute your x equal 1 later in your answer and y equal to this one. Then you get the answer. Okay, so I will just leave it as your homework also. This one you take as your homework and do in your revision time.
So we will discuss it in next class, is it?
No, this one is your homework because the same concept.
Oh, so just do it for ourselves, is it?
Yeah, it's the same concept just now. If you understand, sorry. If you understand example 9, you should be able to do example 10. Same concept. Same concept. Only this one, let me drink water. Only this one is the tangent line. He asks you to apply what you learned just now. What I mean by tangent line of this equation? It means dy dx. He asks you to do differentiation. Just now, example 9 is just a very direct instruction. But how do you apply this red color quotient rules when you need to find tangent line? You see the tangent line in the question in final exam or test 1. It means ask you to differentiate the equation. And this one differential equation, you have the fx and gx. So you just apply what you learned in example 9 in this one. And then you substitute this point and this point inside the final answer. This is x and y coordinate. X and y. Okay? You study as a homework. Quite lengthy, yeah? What else? Good news for you. Good news, huh? I give you this table. Means this one is your life jacket in test and final exam. This summarizes what we learned so far. For example, if you differentiate constant value, what you get, how you solve for multiplication. You see, comma mean differentiate lah. Okay, when you have an x, what do you get? When you have multiplication, what do you get? When you have a quotient, divide one, top and bottom, you use this one. And this one, I think Shakir expert already. When you differentiate e power x, what do you get? And this one is minus 1 you get. Okay, so this is just a table for you to do revision. Okay, important table. Okay, we will continue with trigonometry in our next class, which is tomorrow, 12 p.m. Okay, let me end the recording.